More than a month. No. Yeah. I didn't know. I know. More you go. I was there. That's right. I know I looked at it.
Yeah. Like the same level of boring ground letter that doesn't have predictions.
Really no actual stuff that went in.
Yeah.
Telling you purged and everything.
Yeah, help your brain to go.
Okay, so page 14. I think a lot of what you're going to see today, you're already going to know. It's just the notations will look a little different, but the big picture is Pythagorean theorem will help you get your magnitude. Inverse tangent will help you get to your direction. And then sine and cosine will bring you back to your horizontal and your vertical components. Okay, so magnitude is the length of a vector. And this can represent speed, distance, or force. Okay, so if I want to find the magnitude of vector v, it's just the square root of a squared plus b squared. We talked about how we don't have to worry about dealing with the negative, right? We know that magnitude is just going to be positive values. Okay, so then find the magnitude of the vector with initial point A and initial point B. So yes.
Do you want us to keep it in root form?
Yeah, leave it in radical form. If I ask you for approximation, then you can give me approximation through three decimal places. Okay, so magnitude. Well, I think the strategy here is we get it into component form first, and then we can go through our process. Okay, so first, let's get it into component form. So we know that's going to be x2 minus x1, and then y2 minus y1. Okay, so now the vector form, then, or sorry, component form, now we can find the magnitude, right? So I think component form is always the first thing you want to go for, because if you get that component form, then everything else, I think it comes easily. So, magnitude, so thank you. Okay, direction. Direction is involving inverse tangent. So direction is the direction is which way the vector is pointing in. So the formula that we're going to be using is inverse tangent. But we also know that this is just a starting point, right? If I want to get it into standard form, I have to involve 180 or 360, depending on which quadrant is supposed to be pointing in. Okay, so these examples find the direction of vector E. This is already in component form, so right, which quadrant is this vector pointing in? One. So anything that we get, we can just keep, right? Our reference angle will be our standard position. Okay, make sure you're in degree mode. Tell me what you get for your degree. Yeah, let's just round to 32 degrees. Okay, find the direction of vector F. I can always get this back from unit vectors into component form. What's component form for this vector? Yeah, -6, -7. Let me just drop the I and J and put a comma between. Okay, put that into our calculator. But which quadrant is this in here? Third quadrant, right? So I got to do what with this 49? Add 180. Okay, it says if the direction of vector x is 50 degrees, how would the direction change for each of the following? If I multiply the vector by 5, it's not going to change the direction, right? It'll increase the magnitude, but there's no change in direction. It'll still point in the same quadrant that it's supposed to be pointing in. So, nope. So for instance, imagine x was 34. Right? It'll be 15, 20, which is still moving in the same direction. It may be a little longer, maybe a little bit shorter, but no direction change. What's negative 3x going to do? Right, it's going to be opposite, right? So if this is 50 degrees, sorry, then the opposite would be 50 plus what? 180, yeah. And it's always going to go in the exact opposite direction. And if I have 1/2 x, same thing, it'll make my vector shorter, but no direction change. Okay, so we know how to get from component form to magnitude direction because we know Pythagorean theorem will get us there, and then inverse tangent will get us to our direction. But if we're starting from hypotenuse and theta, we can work backwards using sine and cosine. Right. So here's a instance here. Let's say I had theta, and let's say you're given the magnitude of a certain vector, which is the hypotenuse. If I want to find the horizontal and vertical components, I just have to involve sine and cosine. So we know that cosine of theta is equal to what? Yeah, x over the magnitude, or x over the hypotenuse. And so if I want to find the magnitude of that vector, cross multiply and divide. I'm sorry. If I want to solve for x, I'm not trying to solve for magnitude, I'm trying to solve for x. Yeah, just cross multiply. So x is equal to the magnitude times cosine of theta. And that'll get us that x component. Okay, you guys, we already know this. We practiced this with that Harry Potter task. Okay. If I want to get a create a relationship involving y and the magnitude, I'll use sine. Sine of theta equals y over the magnitude. Cross multiply. Okay, so we can save a step. We don't have to keep creating these trig ratios if we know that we can just use this formula here. So anytime I look for x or y, I'm just going to do magnitude times cosine theta or magnitude times sine theta. So it says find the components of vector g if it has a magnitude of 5 and direction of 25. So I'm just going to put this formula into component form, and then I know I'm just going to always use this. To build my vector. Right, so there's my horizontal component, there's my vertical component. I just kind of arranged it from cosine and sine that we know, but we just save an extra step if we already know what that formula is going to be. Okay, so our magnitude is 5. And our direction is 25 degrees. Okay, so just enter information in. 5 cosine 25. And then 5 sine 25. So I know my vector is going to be 4 units, 4.5 units to the right, 2.13 units to the right, and I can build my horizontal vertical component, right? So we're just having to know how to go back and forth between component form to direction magnitude, and also direction magnitude back to component form. Okay, so classwork. We'll do 135. 39, 41, 43. And 45, 47, 49. So 135, work to get into component form first, and then from there, Pythagorean theorem will get you to your magnitude. Nope. Yeah, just plug in the calculator, and then it gets you the signs that you need. Yeah.
I'm like, all.
All this. Is really up to this. Well, we also need to draw the like there's something that it's not. So this is a good one. So you see how this is. X, so X is over 5. So 1/2 that is going to be divided by 2, with 2.5 so the starting is not here. 2.5 where you set that. So if I have y minus w, your y, which is this we did y, whatever the direction is good for you, minus w, you know how w is going down. So I don't think it's just instead of going down, but it'll up. That should upgrade. That upgrade instead of flat. It's basically I'm just adding two vectors together, and whatever one ends at the yeah.
I just actually to just made it.
So you only start here, but this is negative. So negative W means you got to actually. Yes, it is. Yeah, so let's say this is the 3, and this is the second one, right? So then your results vector is, what's the vector that's going to take you to the beginning to your end point? So if I were to add these together, this is what it is. So if I have a vector like this, let's say it was over 3 and 4. I want to find the magnitude. And then refine the sure, like it's working. Yeah, it's a magnitude. It's just fine. Yeah. So it's E or whatever that is like. That means we're gonna take, see how the is. Down over to. That means 3W, that means you're gonna multiply it, so you're gonna make everything.
I haven't been to the airport. I'm so proud of you too.
Oh, man.
Oh, got it.
Yeah.
Guys, if you can just leave your worksheet, I just want to just walk around and just check that you're finishing up.
Not prize. We might have started. You would understand. What?
We both cover. I got it. I'm not checking. You know, I got this. Get like.
There's 30 minutes of all that.
It really is.
Yeah.
Yeah, but you know that.
I think that's one thing.
I
just think.
Yeah.
45? One point eight.
Yeah, those are examples. Okay, for you to jump for
You have to add 60. I know.
I'll be fine. Or what's wrong with 43? Let me see, that's pretty also for.
Oh, sorry. Sorry, guys, I was in the wrong mode. Negative 8.6, is that what you guys got?
Yeah.
Yeah, sorry.
For 43.
I was in the wrong mode.
Let's go.
I'm done looking at the- There's almost different than being able to look. What do you-
Sure, here for X. And then 3W, that means I gotta go over 6 and down 12.
Yeah.
So, it's like they're here. Is it controls them after, which is, I say, then also it's strong, or we not just, it's starting from here, that's true. You're gonna find the evidence for something for that. If you're ready, that's. I gotta go. You should be able to binge within 5, I think.
It's pretty, I also.
It's gonna, like, you don't have to, you have like 2 really strong, you know?
Okay.
I don't think you have to worry about time, like, it's pretty. Nice one, this one. Yeah, I would. I just didn't know, I didn't like.
So, yeah, was it pretty short?
I was like, 3.5. Very tight. Like, I just talked about like, like, increasing industrial revolution. Like, so I think technology. Yeah, just, that's what 2 pieces, I don't know. Versus usually want to do like, one time, it'll be okay.
Yeah.
You know, the use is probably.
Oh, yeah.
Alright, you should agree with this one.
Well, I know, okay. You
Oh.
know?